This is a lesson on dimensional analysis, which is a way of doing proportional reasoning. So I'll do a couple of problems here using the traditional and the new method. I recommend you take notes on your own page, follow along with what I'm doing. Problem number one, let's say we're given 37 grams of aluminum. And suppose you want to find the volume, which would be in cubic centimeters. This is proportional reasoning using density. So on my periodic table, I can see aluminum is 2.70 grams per cubic centimeter. So traditionally, 2.70 grams, 1 cubic centimeter. 37 grams, I don't know how many cubic centimeters, but my calculator will tell me the answer. So my calculator tells me the answer is 13.7 cubic centimeters circle. Traditional. Dimensional analysis is doing the same thing in a different way. I will start with a given, multiply by a conversion factor. So this is the key to the whole method, is to say a factor is multiplication, and this conversion factor will always be a ratio. Something on the top, something on the bottom. In this case, my given is 37 grams aluminum. My conversion factor will be density. Dimensional analysis says think about what you want the answer to be, in this case cubic centimeters. Think about what you started with and then set up your conversion factor appropriately. I want these grams to die. So I'll put grams on the bottom of my conversion factor here so that grams will cancel grams. I want cubic centimeters on my answer. That has to be on the top. This will be the density. I just have to tell the truth. 1 cubic centimeter, 2.70 grams. This is dimensional analysis. I will multiply by what's on the top, 37 times 1. I will divide by what's on the bottom of the fraction, 2.70, and that will be my mathematical answer, which will come out to be 37 divided by 2.70. It'll be the same answer I got before, 13.7, label it cubic centimeters. So this right here is what dimensional analysis looks like. There's no x. It is proportional reasoning. It just looks a little different. Here's a second example. This one will be involving grams and moles. Given 1.24 moles of calcium chloride. Find how many grams that is. Traditional proportion. Find the molar mass of calcium chloride. That's 40 plus 2 times 35. So that's 110 grams is 1 mole. So I can write it like this, 110 grams over 1 mole is the molar mass of calcium chloride. And I have 1.24 moles. So then X would go on the top, 1.24 moles would go on the bottom. And once again, I get out my calculator and I figure out the answer. So my calculator is telling me X equals 136 grams of calcium chloride. Final answer. Dimensional analysis will look like this. It always looks like this. Given times conversion factor, which is a ratio. something on the top, something on the bottom. I get an answer from that with a label on it. So here the given is clearly stated, 1.24 moles calcium chloride. I still have to label everything. Times conversion factor, something on the top, something on the bottom. Grams is the answer desired. I need to decide what goes on the top, what goes on the bottom. Moles must die. Moles must go on the bottom. Grams must be in my answer. Grams must be on the top. Need to tell the truth. It is 110 grams per mole. That hasn't changed as my method changed. It just looks different. This is the dimensional analysis setup. And I do the calculation, 1.24 moles times 110. I can skip the dividing by 1. Same answer that I got before, 136 grams of calcium chloride. This is dimensional analysis. There was no X. There was simply a setup saying multiply by the right ratio, get the right answer. Now I'm on assignment 51, which is a homework assignment. This problem set is trying to teach you how to use dimensional analysis effectively. All of these problems can be done with traditional proportions, but dimensional analysis is something that you should learn how to do. Your textbook speaks this language, and it may be something that is really easy for you, and it's a better method than traditional proportions. All right, so here's what the instructions say. For each of the following setups, all of these here, determine whether the conversion factor is set up correctly. You can see here's a conversion factor, here's another conversion factor. Each problem has a conversion factor. The second instruction is if the setup is correct, cancel out the units of measurement, what dies, calculate an answer, you'll already have a label. If the setup is incorrect, rewrite the problem with the conversion factor written correctly, and then solve. Here's the first example. 23 grams of aluminum is the given. Conversion factor is a molar mass. But this one is written poorly. If I say, will grams cancel grams? The answer here is no. This is upside down. So this one I cannot solve yet, but I can rewrite the problem so that it looks like this. 23 grams aluminum times mole on the top, gram on the bottom. Now grams will cancel grams. What's the truth? 1 mole is 27 grams. That then becomes a calculator problem, which I answer and get 0.85 moles. I already know the label because there it is. It is aluminum. Looking at the second example, try to decide yourself, is this correctly written or not? Once again, this conversion factor is a molar mass. In this case, it is correctly written. Grams will cancel grams. I don't need to rewrite anything. All I need to do is get my trusty calculator and type in the numbers. I multiply by what's on top, divide by what's on the bottom, and I get 12.2 divided by 207. 0.059 moles of lead. There we go. So this is what dimensional analysis looks like when it's correctly done. As I said, it's a skill you want to develop. Some of you will really like this, some of you won't. If you don't like it, you can go back to traditional proportions, but learn it first and then decide second.